Hi students, today we will discuss about the electric field intensity at a general point due to a short electric dipole. In our previous class, we already have discussed about the electric field intensity for an axial point or an equatorial point, and now today we will discuss about any arbitrary point. So here one dipole, for this dipole we will calculate for this. I redraw this dipole again. Minus q charge and plus q charge. The separation between them is 2a. Now there is a point, so any arbitrary point. Suppose you connect this point to the midpoint of the dipole, then any of the angle, that is theta. We know that the direction of the dipole moment for an electric dipole is from negative charge to the positive charge. So if this is positive and this is negative charge, so the direction of the electric dipole moment of this dipole will be this one. This is the direction of the dipole moment. Now if we split this into two components, one component will be along this direction and another component will be along this direction. So if this is the direction of P, so this component will be P cos theta and this component will be P sin theta. Now just see in this diagram, for this P cos theta, this point A is an axial point. So here you can write, for P cos theta, point A is an axial point, Therefore, electric field intensity at A due to P cos theta is, suppose we take E1 is equal to, we know that for the short dipole the electric field intensity on the axial point is 1 by 4 pi epsilon naught what p 2p by r cube. So here we will get 1 by 4 pi epsilon naught 2p by r cube. Here at the place of P we will take what? P cos theta, because this is the axial point for the P cos theta. So here we will get P cos theta. So this is the electric field intensity due to the component P cos theta at a point A, and the direction of this, that will be along this direction. We know that for the axial point. Similarly, for P sin theta, point A is an equatorial point. Equatorial point, if we extend this such a way, so for the P sin theta, this point A is an equatorial point. See here, P sin theta is, this is the P sin theta. Imagine extend this, so this A is the equatorial point. Therefore, electric field intensity electric field intensity at A due to P sin theta. Suppose we take E2. So what is the expression of the equatorial point? The expression of the electric field intensity 1 by 4 pi epsilon naught, then P by R cube. So here at the place of P we'll put P sin theta, because this is the equatorial point for the P sin theta term. Therefore E2 is equal to, we can write 1 by 4 pi epsilon naught P sin theta by R cube. So this is the electric field intensity for the component P sin theta. So this is the electric field intensity for the component P cos theta, and the direction of E2 will be along this direction. Sorry, you can write, sorry, not this one, you can write this direction. This is the direction of E2 and this is the direction of E1. So what will be the resultant? Resultant will be the E. This is the resultant of E1 and E2. Now we have to calculate this E. So from the vectors law, from the vectors we can write E is equal to root over of E1 square plus E2 square plus twice E1 E2 cos theta. So here, see here, the theta means the angle between E1 and E2, angle between E1 and E2, this angle is what? 90 degree. So cos 90 means 0. So this cos 90 will be what? 0. So from this expression you can write E is equal to root over of E1 square plus E2 square plus twice E1 E2 cos 90 degree, and this term will be 0 because cos 90 is 0. Clear or not? Cos 90 will be 0. So from this E is equal to root over of E1 square plus E2 square. Now we put the value of E1 and E2. So E is equal to, E1 means 1 by 4 pi epsilon naught 2p cos theta by R cube. So 2p cos theta by R cube, this square, plus E2 square means, here you put the value 1 by 4 pi epsilon naught P sin theta by R cube, then square, E1 square plus E2 square. After that E is equal to, from here you can write 1 by 4 pi epsilon naught R cube whole square, 2p cos theta square means you can write 4, you can write here p also take here. So p by 4 pi epsilon naught R cube whole square, and there will be 2 square means 4, and this is cos square theta plus here also be 1 by 4 pi epsilon naught. This p will be here, so p, and this is r cube, so this square, and there will be sine square theta. These total things will be under root. Okay, here 1 by 4 pi epsilon naught p by r cube, we take this in a bracket square, and sine theta whole square means sine square theta. So from this term, this will be common. देखो p by 4 pi epsilon naught r cube is the common term. So from here you can take common this p by 4 pi epsilon naught r cube. This is common. Then there is 4 cos square theta plus sin square theta. Total thing will be under root. Now e is equal to, if we remove this from the root, so the square will vanish. Yes or no? Here under the root this square, so if you remove it from square under root, then the square will vanish. So from here you can write p by 4 pi epsilon naught r cube, and there is 4 cos square theta plus sin square. So 4 cos square theta means you can write here 3 cos square theta plus cos square theta plus sin square theta. So from here you can write e is equal to p by 4 pi epsilon naught r cube under root this 3 cos square theta plus sin square theta means what? 1. So from here you can write e is equal to p by 4 pi epsilon naught r cube 1 plus 3 cos square theta. So this is the expression of electric field intensity at any arbitrary point for an electric dipole. Now just you think about that. From this you will go to the axial point, and you can go also to the equatorial point. How? Because in this diagram, if this angle theta is 0 degree, then this point will be axial point. Yes or no? If this theta becomes 0, then this a will be here. That means the a is the axial point. So from here, देखो, for axial point, if you say, then theta is equal to 0. Sorry, 3 cos theta. So theta will be 0. So here if you put that, cos 0 means what? 1. So from here you can write e is equal to p by 4 pi epsilon naught r cube, then 1 plus 3 cos square 0, theta is 0. So cos square 0 means here what? 1. So that will be e is equal to p by 4 pi epsilon naught r cube. So this will be 3 and this will be 1. 3 plus 1 means what? 4. Root over of 4 means what? 2. So we can write 2 here. So this is the what? The electric field intensity for the electric dipole at any axial point. So from this equation we will come back to the axial point. Similarly, if you put theta is equal to 90 degree, suppose this theta, if this theta is 90 degree, then that point will be the what? The equatorial point. Then if you put here theta is equal to 90 degree, then this cos square 90 becomes 0, and we will get the electric field intensity for the what? Equatorial point of an electric dipole. So this is the expression of electric field intensity for an electric dipole, electric field intensity of at a general point due to a short electric dipole. So this is the main formula, and here we just give one example that you can come back from this equation to the axial point by putting theta is equal to 0, and if you put theta is equal to 90 degree, then you also will come back to the point, that means the equatorial point.